Okay, so the next thing we want to do is, in order to change the length or the scale of these objects so we create that curved ceiling, we want to get some kind of an idea of the relationship between any given point up here and this curve down here. And that's just a technique of kind of like the nearest point, like what would be, if we were to draw from here to the closest point we could get on any of these ceiling tiles, what would that line look like and how long would that line be? It's just a way of generating a data set that will give us useful information to create this kind of curved surface. And I'll just demonstrate that as we move along here. So I'm going to move over to Dynamo again, and I'll slide this over, and we're going to look for a special tool here to help us kind of like extract that kind of information. And I have to move my screen over here, so that's kind of why I'm fumbling a little bit. We're going to look for a tool inside of Dynamo, and these always seem cryptic when instructors come up with these devices that you've never heard of before. But it is part of a learning curve. There are many techniques within this that the best way to learn it is to see a whole bunch of I guess, things pulled out of the hat, and then realize that you can also eventually start pulling the same things out of your hat. And one of them is this idea of this distance between a curve or an object and another object to extract some data. So I'm going to right click and do a search for this because it's just the easiest way to find it. It's geometry dot closest point to. And you'll notice when it opens, it's this, like I said, very cryptic about you would never look at, if I was to show you that this existed, you'd never think of why you would use it. So we have to kind of do both things at the same time. The idea is it looks like two pots, and the idea of Dynamo determining kind of like what the distance is between those two, the closest 2 points on the object. So I'm going to select that. And that allows us to put two pieces of geometry together. One is the cubes or the points up here. We're going to use the points. And the other one is the points along the line. So I'm going to take that NURBS curve as the geometry. And I'm going to take the points and plug that in. And I generate nothing that shows up yet because but I'll use a watch box here so I can show the data. And I'll plug these points in. And you'll notice that we have now another array of 121 points. These points now are points along this curve that represent a relationship to another point that's up there. And I'm going to try and visualize that by connecting points up with lines. So let's just slide this over again. And I'm going to grab another tool, a line. Actually, let's see if we can look it up directly. I'm going to close off the curves, and I'm going to look for lines. Oh, here it is, line. Line by a start point and an end point. And we can call this the start point, and we can use the lines so these are the lines on the curves, and these are the lines on the cuboids, or the center points. And this is where the kind of the cool visualization happens. Now we have this connection between the closest point on this line to this cuboid is that dimension. No other dimension is shorter than that. And actually, if I slide over another bit and reuse our watch box, I'll plug this in here. And you're still not seeing, actually, well, let me go one step further. This is actually not useful data to us yet. I'm going to leave this unhooked for a minute. So we have all this series of lines, 121 lines corresponding to these panels. All of these lines have different lengths. And the next thing we want to do is actually be able to extract out the length of those lines. So we're going to use a tool called curve length. Dot length, I think. So if we put in the curve, we'll get out its length. So the line is a curve. And I can plug in the watch box again, and hopefully this data will be more sensible to you, which is kind of what I wanted to get to. So here we have now the idea of the length of the line being between 20, the minimum, And that makes sense because our points down here all the way up to our level of 20 feet, the longest, or the shortest a line could possibly be is 20 feet. And you'll notice that some of the other values go up above that. So we have some that can only be as close as 22 feet to connect to a point on the NURBS curve. With all that said, that generates a whole bunch of very interesting variable data that we're going to use to feed in to control the length of our cuboids. So I'm going to zoom out here a little bit, and I know that becomes hard to read, but this is our cuboid is over here. And I'm just going to plug in that piece of data so you can see kind of what happens. So all of these now have different lengths. If I plug that height into the cuboids, this is where you can really start to visualize what's going on here. So now we have our cuboids are stretched out, and their length or their height is determined by the length of that line, that relationship between this point and that point. And now you can see how the geometry is varying to match that curve shape. So that's the start of getting us to our ceiling system. And really the only thing we need to do now is start figuring out how to trim off and make the data more useful and more controllable so we can make ceiling panels out of it.